Hello and welcome. In this video, I will be showing you how to modify the properties in a retro Sega Genesis fighting game of the player 1 and computer players properties that are stored in RAM. Particularly how to, in this case, change the character that is being played for both player 1 and the computer player. In this case, I'm using Teenage Mutant Ninja Turtles Tournament Fighter on the Sega Genesis. I'm using the Gens R57 Shell emulator mod for hacking. First and foremost, I want to basically cheat and have infinite health, so I need to find the RAM address for player 1's health so I can change it to a very large number and just not die. So the process would be open up the RAM searcher, set to previous value compared to 2 bytes, hex value, and less than. So and then you just get hit, lose some health, and let me change this. Sorry. You lose some health, and then you search the less than, and then you do this again, and you keep repeating this until you find it. I already found it, and I set it to like 7F7F in the Game Genie, so it's a very large positive value, whether it's, in the signed world. So now, boom, I have infinite health essentially. On to the next thing. So now, first thing I want to do is if I want to assume here in the assumption. So this video is going to show you a lot of explaining a lot of things of like when I've done the reverse engineering. I've seen how certain things work, and I can make assumptions on that, and I can test and try and find stuff based on those assumptions. Sometimes I'm wrong, sometimes I'm right. So this will explain a lot of that, the mechanisms of how things work, how I've seen them work, and assumptions you can make based on that to try and find things. And a lot of times, those assumptions, if they're right, it'll save you time. So that's why they're nice. So I'm assuming that player 1 and the computer player both have a RAM address allotted of a certain amount of bytes for all their properties, and so that from the base of both player 1 and the computer player, that there's an offset that's referenced from the base for the different properties. So let's try and find the base of player 1 by first trying to find an easy property that we can search for, that is the player 1's X. So you do your RAM search, right? And you reset, same thing I did, 2 bytes, hexadecimal, let's do less than. So I go back a little bit and I search, and then I come a little bit more forward, and then I search again, and then I go back, and I'm not going to show you this, but so you do that and this and that and this and that, and I find out that what looks like that in the process that the FF0006 is player 1's X coordinate address. So let me verify that by open up the hex editor, and let me change the word at FF0006 to like a bigger number from like 004F to 014F, and see what happens. Well, I didn't do anything there. So let me change it to a smaller number, like 0, right? Okay, now we moved over. You see it moved player 1 over, right? So now we can, now that we've confirmed this, that player 1's base is wait, we haven't confirmed that quite yet. So now let's confirm that my assumption is that player one's base is FFOOO, and the offset of 6 bytes, or 6 bytes from there as a word, or I haven't gotten there yet, but 6 bytes away from there is his x coordinate, right? So this address here. Um, Now and I'm assuming that it's both these. I did the work ahead of time, and that's not just this one here, this 1 byte. Let's test that hypothesis by making you go to debugger and you set a read write breakpoint on that address. Um, I mean, you basically already know it's true, but okay. So see, we see a move the word at 6 bytes away from the address at A0 into register D0. Register A0's FFOOO and offset 6 bytes away from there. So that's correct. So player one's base is FFOOO. The X is 6 bytes away from there. So now let's assume for a second that it's working the same way for the computer player as well. That there's going to be some base, and then there's going to be 6 bytes away from the base. It's going to be its X axis as well. So what we can do is we can look at all the instructions, um, the ROM address of the instructions, all the instructions that read and write player one's X coordinate variable in RAM, and we can set up uh, PC breakpoints for all those addresses, and then we can assume for a second that maybe one of those instructions that references player one's x access by using an offset addressing mode from its base will use that same instruction, but the register in there that is its base will be set to a different base address for computer player, and it will just offset the same thing 6 away from it. So we can make that assumption. So this is another um, thing that you see how computer games work, and you can kind of let's make an assumption real quick and say maybe this is how it worked. So let's set we set all our I already did the work in the past, but I said all I looked at a bunch of different instructions, addresses in ROM that read or wrote to the player one's access, and then I set PC breakpoints, and I look at them, and we see here that um, um, wrong one. Okay, that's the wrong one there. Um, Let me back this up for a second here. I can't remember which one it was that triggered it, but I'm trying to get to it real quick here. Okay, here we go. So this address here at ROM address 22304 reads the 6 away from the base of A0, which is FFOO40. So basically, we see that this address 22304, let's just set that as the only PC breakpoint. We see that here A0's base, the base is FF0000, and then in this instance, the base is FF0040. So now we found, well, let's assume that we found the computer player's base. So, and then its offset is 6 away from there. So we assume that the base for player or the computer is FF0040, and then the X is FF0046, obviously. So let's go to FF0046 real quick, and let's change it to 00, and let me turn off this breakpoint. See how player 2, clone Casey, moved way over here real quickly. So we confirm this, that player 1's base is FF0000, is offset 6 bytes away at FF0006, and then computer player's base is FF0040, and his offset is 6 bytes away for his X, which is FF0046. So with this, we have found out, based on this knowledge, we now know that player 1's range goes from FF0000 to FF0073F, and then computer player's range is FF0040 to FF007F for its properties. So, all right, so now let's take an example here where we copy all the properties of player 1, FF0000 to FF003F, and then we paste that to the computer player, and voila, now the computer player now is you, Leonardo, and the palette is screwed up, and this is because palette 1 is for player 1, palette 2 is for the computer player, so it doesn't match up. Now, I found out the first byte in the from the offset of either player 1 or the computer player deals with like the data for drawing what character it is, so, or appears to. So this is right now computer player 1 is, its values 8-1, so let's change it to like 8-8, right? And it changed to the bug guy. And then if you do 8A, you turn into the cyborg guy that works for the brain. Or works for the brainy bad guy. Or he's, you know what I'm saying. And then if you do 8-5, turn to April O'Neil's clone. And if you do 8-4, turn back to Leonardo. If you do 8-3, well, 8, I think it doesn't change anymore after that. So 8-6 turns the clone Casey. 8-7 turns to the Flay guy. So it's kind of cool there, you can see that. So I hope you like this video. Like, subscribe. I hope you like it. Leave some comments, some questions. I'd be happy to answer. Thank you for watching.